My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 510. In this lecture, we will try to understand PageRank algorithm. Very important, very useful type of featureization of graph data type, especially directed graphs. If you have directed graph, very popular featureization of directed graphs is called PageRank. This is very popular algorithm. It is early prototype of ranking algorithms that Google used. So the best way to understand is obviously to go to Wikipedia. We will give a brief overview of what PageRank is without going into too many mathematical details. The history is this. PageRank is actually named after Larry Page, who is one of the co-founders of Google along with Sergey Brin. So the task that PageRank is trying to solve is this. You can think of whole of internet literally as set of pages. You can think of each page in internet. Imagine this is, let me say this is yahoo.com, and let's say this is cnn.com. Let's say this one is MIT. This is yahoo.com, this is cnn.com, this is mit.edu. You can think of each of these pages on the internet literally each of these pages on internet as a vertex, isn't it? It's a vertex. It's a vertex of a graph, isn't it? Yes. You can think of each of these pages on the internet, literally each of these pages on internet as a vertex or a node. And if there is a hyperlink from yahoo.com, if there is hyperlink from yahoo.com to to, for example, if there is a hyperlink from yahoo.com to mit.edu, isn't it? Let's assume this is a hyperlink. Let me assume this one is a hyperlink from yahoo.com to mit.edu, which links us and takes us to which links us and takes us to take cnn.com also. cnn.com. If there is one hyperlink, if there is an hyperlink between yahoo.com and cnn.com, and you have to add an edge. Just see, you are adding an edge. Means there is a hyperlink from yahoo.com to cnn.com. There is a hyperlink from yahoo.com to mit.edu, isn't it? That directed graph, the direction represents hyperlink, isn't it? Because the link is from yahoo.com for a user to go to cnn.com, isn't it? So you can think of your whole web itself, whole internet itself, or the web structure between the pages is basically a directed graph. You can think of whole thing as a directed graph. Very interesting concept. So when you think of this is a graph, remember in Google search, one of the challenges that Sergey Brin and Larry Page were trying to solve is the ranking problem, isn't it? There is a problem, ranking problem. Which pages are more? What is the ranking problem? Which pages are more important when you Google search, isn't it? Which pages are more important when you Google search? When you type some term, let me say I type term Steve Jobs. When you type some term in Google search and press enter, you get sequence of results, isn't it? You will get sequence of results. The biggest challenge here is not finding the words. It's finding the words in search bar, isn't it? Which are in search bar, because you will get millions of pages. How do you rank them? That is important. You will get millions of pages. How do you rank them? That is very important task. So they want to come up with a method to rank the importance of each web page on internet. So the very interesting idea. So what they done in a nutshell, you can think this way. I can give an intuitive understanding of this. For example, imagine this is, let me go to Wikipedia. Yes, imagine this is my Wikipedia page. For example, imagine this is web page A. Just I am assuming this one is which one? Yes, this one is web page A, web page B, web page C, web page D, web page E, web page F, isn't it? This is web page and so on and so forth, isn't it? Now your web page B tends to have large value, isn't it? Your web page B tends to have large value. What's the reason? Just let me explain. Yes, let me say like this. Now your web page B tends to have larger value if there are lot of pages linking to this, isn't it? There are lot of pages linking to web page B. If there are lot of pages that are linking into B, that means B must be a trusted source. I can say B is a trusted source, like CNN.com or MIT.edu, like Yahoo.com. If lots of pages in internet are linking into B, if the destination is B, then B must be an important web page. If lots of pages in internet are linking into B, if the destination is B, then B must be an important web page. This is first point. The second point is, if I get lot of links from other popular pages, isn't it? If I get lot of links from other popular pages, look at the simple thing. Imagine if I have page here MIT. If I have page here MIT.edu, I am getting lots of links from other pages. Other pages means what? If these pages are also let me say, if these pages are also important, I am getting links from which pages? Let me say this is my page. I am getting links from harvard.edu, cnn.com. If these pages are also important, if these pages are also important, isn't it? If these pages are also important, for example, if I have page on MIT.edu, if I have link from harvard.edu, let's say I have link from cnn.com, the important thing here is cnn.com itself is very important website. Now because I am getting link from cnn.com, my page value also increase. Whose page value also increase? MIT.edu page value increase. And of course the big question here is, how do you compute? The big question here is, how do you compute these values? That's important, isn't it? What is the big question? How do you compute? The big question here is, how do you come up with important score of each page? There is a bunch of graph theoretic mathematics behind this. In a nutshell, this is what PageRank does. PageRank works by counting the number, and two things are important. Number and also quality of links is important. The number of links matter, but the quality of each of the links also matters to determine or to estimate how important a website is. The underlying assumption that they are making here is that important websites are likely to receive more links from other important websites. That's the core idea. That's the core idea behind PageRank algorithm. The other way of looking at it is this. If you look at algorithmic specific, the PageRank algorithm literally gives probability distribution across all the vertices or all the nodes. It will give you basically a probability value. It literally gives you probability value for each of the probability value of each of the web pages. Let's say I have web pages U1, U2, let me say U3, U4. Let's say web pages are U1, U2, U3, U4. All these are web pages. It will give you some probability value here that represent that the likelihood of random person clicking on these links to arrive at particular page. This is a probabilistic way of understanding PageRank. PageRank says I will give one value to each web page such that this is probability of a user landing on this page. If probability, I can say, let me repeat this point. PageRank says I will give one value to each web page. Each web page means here, what is web page? Each user, this is a web page, this is a web page, this is a web page, this is a web page. For each user it will give a value, isn't it? That probability value of a user, it is the probability of user landing on this page. If he was randomly clicking across all the links on the internet. So that's what this means. There are many variations of PageRank, but in a nutshell, what PageRank algorithm gives you in a nutshell, PageRank algorithms gives you what it gives you. There are many variations. Variations means many variants of PageRank means there is false or spoofed PageRank, manipulating PageRank, Google directory. Just I request you to go through these variations of PageRank algorithms. But in a nutshell, what a PageRank algorithms gives you is, given a directed graph, the PageRank algorithm will give each vertex UI, it will give a score that represents how important this vertex is in this directed graph. Remember, PageRank was designed to search. PageRank was created for internet or web search. It was not created to recommend friends, but still this is very important property of a graph or given vertex. If it is more important, there is a higher chance. Now logically think about it. If a user in a directed graph, if a user has high PageRank score, that implies, but this user is more important because lot of other users and high important users are linking into him, isn't it? So there is another user who is also have high importance, and there are many users linking into UI. That's why UI score is large. So PageRank will tells us the relative. The PageRank will tells us the relative importance or the relative weight or the relative score of each of these vertices based on how important they are in the graph. Obviously, if a user in our friend graph or in a following graph tends to have lots of followers, lot of big followers, let's assume this user means what? UI. Let's assume this user UI. Yes, let's assume this user UI is user. Let me assume he is a Bill Gates. Yes, user UI is Bill Gates. Bill Gates probably followed by Mark Zuckerberg, and he is followed by Warren Buffett, isn't it? And other big players. And he is also followed by random small people like me or like you. The very fact that there are lots of important people following Bill Gates shows that Bill Gates must be an important person, and hence he has significantly higher chance of being followed by random person. For a random UJ, for a random UJ, let me say this is UJ. For random UJ, because this is what is this UI, this is in general celebrity. I am assuming this UI is celebrity, just UJ is a random person, isn't it? He has much higher probability of getting an edge from a random user UJ. If UI is celebrity, that celebrity has higher probability of getting an edge from a random user UJ than if it were me or you, we are not very important. So from a random UJ, there is a very small chance that we would get an edge, isn't it? Bill Gates will get an edge. We will, but very less small chance we would get an edge, isn't it? For somebody like Bill Gates, there is a very high chance. PageRank computes these for us. If you want to learn more about the best source is Wikipedia. This gives lot of details about basic algorithm. There is also Python code. If you go through Wikipedia, you can find Python code, all the modifications. There is a tons of research on this topic, by the way. So what we will do here is, there is something like a Network X, isn't it? Network X, the library that we are using for all graph processing, already has PageRank implemented for us. We don't have to implement PageRank ourselves. That's the beauty of using existing libraries. We picked up this image from this Network X documentation. Just Google it. So if you want to compute PageRank, it is as simple as taking graph, asking to calculate PageRank. The hype, just this is the code anyway. FB underscore featureization IP. This IPython notebook, I will keep this IPython notebook in comment section as well as description section of my video. Just see, they're taking the graph and calculating. You can take the graph and you can calculate PageRank. The hyperparameter alpha, that's all. There is 0.85 alpha value is a reasonable value of hyperparameter. Once I get it, I literally get my whole PageRank value for each vertex UI, isn't it? Here I'm printing, what am I printing? Minimum value, maximum value, and the mean value of PageRank given to each vertex. As we mentioned earlier, probabilistic interpretation of PageRank is a probabilistic interpretation of PageRank is, it is a probability value, isn't it? It's a probability value that a random user would land upon this page if it is a web search page. So all these values are small. In the actual Google PageRank algorithm, they don't use simple probabilities, they use actual log probabilities. Here we are using simple probabilities. We are also imputing for those nodes which are not there in training data. We would simply use mean value, because you remember there are some vertices that are not there. There are some vertices that are not there. There are roughly I can say something like, there is something like data. This is one. There is some data. This is, let me say, this is training data. Let me assume this is training data. This is, let me assume, test data. There are roughly 80k. There are roughly 80k vertices that are not there in your train data, but they are in test data. For those, what we will give PageRank values. You just give the mean PageRank value. So the way we will use this is for both of the vertices. You have U1, let me say you have vertices U1, U2. We will create the two features. The first feature is PageRank for this vertex U1, PageRank for the first vertex, and as well as PageRank for the second vertex. So we create two features using PageRank algorithm. As far as this case study is concerned, we just have to understand logically what PageRank means and why PageRank could be an important feature which we discussed in the last few minutes. I request all of you to go through this particular lecture. If you have any difficulty, please keep a comment. Thank you very much.